Okay, this problem is really just a graphing problem. It's a word problem really for the graph. Okay, and the graph is just going to represent what the price is going to be um, at the million pounds. So, or how many pounds of sugar that each will supply at certain prices. So in this case, we're going to look at lowland and then highland, and we'll look at lowland first. Okay, and we know that the slope of the curve is 1 cent per million pounds. So every million pounds it goes over, right? Every million, or probably a better way to look at it is if people are willing to pay 1 cent more, there's going to be a million pounds more supplied. Okay, so that's the way this is going to work. So at 15 cents, lowland is at zero, right? That's the minimum supply price. They're really not supplying anything, but that's that's where they get down to zero. So 0 pounds of sugar at 15 is where we would start. So let's do this for lowland. Okay, so 15 cents, and then for every cent that the price goes up, and we'll talk about how the price will go up later. That has to do with demand, right? But we're just saying if the price were to raise to, I don't know, 75 cents or 35 cents, whatever, right? We'd have to take 1 cent higher, so 16 cents. Now there would be, and it's not on this graph, but at 16 cents there would be 1 million pounds of sugar supplied. Okay, so that'd be over there. But this graph isn't that granular. So if we go out to 10, what would 10 be? Well, 10 would be if there was 10 million pounds of sugar supplied. That would mean that based on the word problem here, the price had gone up by 1 cent for every million pounds. So now that lowland supplying 10 million pounds, because that's what that 10 means right there. Lowland's supplying 10 million pounds. That means that the price must have gone up 10 cents. So it would be at 25, and so on. So you can, and that's the slope of the line. So at we'll just go out to let's go out to 50. So at 50, that means that 50 cents, so it'd be 50 more cents than 15. So at 65 cents, the amount supplied in lowland would be 50 million pounds of sugar. And you can read this chart all the way up at wherever you're at. Like at 35 cents, that means that 20 million pounds of sugar will be provided. And that makes sense with this. It says for every 1 cent an increase in price, the sugar producers supply 1 million more pounds, right? So at 35 cents, I'm at 20, right? But I started at 15, so that makes sense. So I started 0 at 15, so 20 more cents would get me 20 million more pounds of sugar. So that's where I would be on the chart. And so that makes sense. You could plot every one of those out if you wanted to, but that's not how this works. The graphing thing works here. So we can just label this lowland, and then we do the same thing with highland. Highland was 10 cents. So we go down here and do this again, 10 cents, and it's the same slope, so it makes sense. And we can just to keep it out from covering each other up. But 60 million pounds, what's the price got to be? Well, that's got to be 60 more cents, right? And so at 70 cents, there would be 60 million pounds of sugar. And then make sure you label them correctly. That one's highland. And so that one should be correct. Then you just do final check, and well done. All right, go try to do it yourself. Now, if you're doing this with Pearson, you will, if you do the help me solve this, it will change the numbers on you. Let's see let's look at this similar question. So this similar question. So now this version of the question, so you may get a different version is my point. This version of the question just says 15 cents for lowland and 20 cents for highland. So what's the difference? Well, really that's just telling you what the cents are at zero. That's the the y-intercept here. Okay, so that's where the starting point is on that graph. So hopefully that helps.